Hello everyone and welcome back. We will now begin session 2 where we will get an update from the Integrated Design Studios.
This is an update of our what you call Integrated Design Studio. In Design Studio, what we are trying to achieve is we are trying to change the way we design our buildings. We would like to have a better technical outcomes, and we would like to have an architectural outcome too. And what we do is that we involve in this activity, we have 3 universities involved, and we have the client, RIA client, and the RIA consultant, RIA student, and RIA academics. So we involve in those projects in there. An Integrated Design Studio, we have the several steps we do in there. First one is an initial design studio. We develop what you call, by looking at the literature, we look at how we do this, okay? And that involve what we call first steps is integrated design research. We do integrated literature review, how we are going to do this, why we are doing this. And after that, what are we going to do? So we learn it by doing those integrated design studio. And in those design studios, students generate the ideas, and then they do the research. And then after that, once a student integrated design studio finish, we have the consultant come in and feasibility vetting reports there. Based on those reports, we have generated what you call catalog of the technology that we could apply in different what you call building typology. One of the outcomes that we got out of this is a catalyst for integrated design studio document. This is a living document that we have. And how do we do this integrated design? We are doing it, those sort of what you call integrated design studio. Along the way, we are recording and learning from our experience. At the same time, we have the zero carbon catalog happening for the various design, what you call building design typology. And these are the example of our student, what we call outcome and the output from the design studios. And today's schedule, you can see it in here. Wendy will talk about tropical and subtropical. And Georgios will talk about aged care and multi-use facility. And Brendon will talk about varying building scale and complexity. And then Dominik Holzer will come in and talk about translating integrated design studio process, our learning into how do we do it in industry practice. Sorry, Wendy, it's all yours.
So thanks, Lou. So as he said, I'll talk about the 2 design studios that QUT have been running about in subtropical and tropical zones. These studios have just finished last week, so we haven't finished the project yet. We still have some work to do. So the client for these 2 studios was Bolton Clark, which is an aged care provider. And their constraints, their requirements for our designs, that they had to be mixed-use buildings that incorporated an element of aged care, and that any proposed solutions needed to be proven, show a return on investment, although that return needed to consider a lifetime cost of ownership and could also consider non-financial benefits. They needed to consider the effects of elderly residents and conform to their principles of ESD. They, interestingly, don't have a corporate strategy of net zero energy or net zero carbon at the moment. But as well as the iHub and ARENA requirements of can we show energy reduction, HVAC utilisation or renewable energy, that's better than business as usual. So for the first point, some of the mixed use typologies that were proposed by the different teams were a mixture of different types of aged care requirements. So there's residential aged care. So these are people who need full-time care. At the other end are independent living units where people are independent in all stages of all facets of their life, and something in between that are often called assisted living units or supported living units, where people can live independently for a lot of their daily activities but require somebody in to help them with one particular thing. But then other types of use were mixed into these buildings, which could be other residential, predominantly student or multi-generational families, some retail use, some services, and particularly medical or allied health related ones, community services, and education, in particular TAFE and university teaching integrated into aged care buildings because of the need for more training and more skilled workers in this sector. So I just want to show a couple of examples from each of the different sites. So the first site is in Caboolture, subtropical southeast Queensland. It's a brownfield site and it's on Gubbi Gubbi land. So in the middle of this picture, you can see a stage 1 site. So this is a new residential aged care centre, which is actually our Living Lab 1. And all the other parts of the site are staged for future redevelopment. And this whole site is right in the middle of Caboolture. Across the road is a major shopping centre and all the main CBD services just to the right of the picture. So a couple of samples of student works from this. This example is from a construction management student who is looking at the co-benefits of strategies that can have an energy impact as well as occupant well-being. So he was looking at vertical greening systems, and first of all was looking at literature related specifically to subtropical regions and showing the thermal benefits, the financial benefits and other benefits of 4 different types of vertical greening systems. Interestingly, particularly reducing the ability of these greening systems to reduce the temperature of walls and of the air around walls and affecting the urban heat island effect. Then he was relating those physical benefits of vertical greening systems towards the 10 design principles for designing for dementia, which was one of the key interests of the client. So looking at, so one of the advantages of this approach was if we're looking at solutions that can address energy things, can we also have multiple benefits that increase then the financial value or the cost value equation for particular solutions. This design by our co-designer Tibby is also looking at an integrated approach, looking particularly, and again it was a multi-generational living situation, but looking at the integration of energy, water and health approaches, not untypical for seeing some, solar panels on your roof and for solar shading, etc., but incorporating the vertical greening systems that the previous student, Zia, had looked at, but also looking at the use of water as a cooling agent to the mechanical systems, because on this particular site that slopes downwards, there is already a stormwater bio basin retention pond down on this site. By moving it up closer to the building and being able to utilise it both for its stormwater and rainwater management system, but also as a cooling agent for the building. So I guess one of the strategies that we need to look at is how to integrate all of the services and not just energy only, but energy and water in particular, very closely aligned. The third solution was looking at the natural ventilation or the stack ventilation method combined with internal vertical green wall systems. An important thing to note for this, for the subtropical climates, is that more than 65% of the time of the year, the natural environment is within the 26 degrees, so is quite comfortable without any need for heating or cooling. So a mixed mode approach to buildings is a climatically responsive way. So enhancing natural ventilation is an important figure. For the tropical site, there's a site in Cairns, a greenfield site, which is on the Gimuy Walubara Yidinji land. So there is an existing residential aged care centre on this site and some greenfield land that the client may purchase and develop in future. So it offered lots of opportunities for the teams to consider in their designs. I should point out that collectively these two IDS projects, we had 26 Masters of Architecture students, 2 electrical engineering students, a mechanical engineering student, 3 construction management students, and 6 industry consultants, as well as academics in architecture, sustainability, and energy systems. So here's Phoebe's response to a campus model approach in a tropical zone. One of the interesting things from a renewable energy perspective of thinking about in Cairns, because of its high latitude, having PVs on all orientations is actually a reasonable solution for maximising your renewable energy. This particular response by Joanne So, the architectural students were asked to consider 9 key design principles that are important for considering aged care. So considering dementia and social well-being, equity and inclusiveness, etc., and having to then understand what are the design principles from a building operations point of view that addressed each of these. So, for example, looking at the top left, that passive cooling and ventilation are possible up in the tropics, but you need to really understand both the temperature and the humidity. But a lot of the time of the year, you can get good occupant comfort through natural means without any additional cooling. But it means that you need to have deep overhangs, very narrow internal spaces, and a very permeable building envelope. So this is one of the solutions that I guess we think is one of the best integrated solutions. So this is a multi-generational residential block with the bottom level being a market hall and childcare, designed by Tristan. So it features a narrow floor plan with operable and stacking windows, so with a large openable portion and ceiling fans for your natural ventilation. Interestingly, a folded second skin roof or a double roof, which is not uncommon in hot tropical areas, but not common in Australia. So this second skin roof has been shown in literature to reduce heat gain by somewhere between 21 and 75%. But also this particular roof increases the hosting capacity area for building integrated PVs. The design also includes hydronic floor heating in slab. I'm not convinced that that's necessarily a tropical solution yet, but also CLT and timber construction and some internal joinery, etc., looking at embodied energy. 2 of the construction management students were providing advice on embodied energy and the materials suited for these particular climates. One of the electrical engineering students was looking at the feasibility of hydrogen into the future, because Twiggy Forest has announced some hydrogen projects in Queensland, and all aged care facilities are required to have backup generators of some sort. So it was looking at a comparison of diesel, both the capital costs and fuel costs for running diesel as your backup power solutions compared to hydrogen. And he applied that strategy to Tristan's building shown in the previous slide. So overall, the things that I thought were missing from all of the designs that the teams came up with was, in my view, an in-depth climate analysis that showed daily and seasonal extremes and the duration of some of those extremes. Most designs, including building simulation models, look at averages and not the extremes. But for elderly people in particular, but for all of us, we live in the extremes. There was also generally not a consideration in the design solutions about the different indoor comfort needs of different building users in the different uses of the building. It seemed to be generic approaches across all building classes. And there was not an evaluation of the energy impacts or strategies that you need for mixed mode or hybrid buildings. So buildings that have both natural ventilation plus cooling with mixed tenancies. So if, for example, a building can operate in natural ventilation mode for 60% of the time, what is your strategy for closing up that building when it needs mechanical cooling to make sure that you're not losing all that coolth out to the external environment? So you need things like, I think, reed switches, for example, on windows and doors. So what's happening next in this studio is a feasibility assessments by the consultants. So we will simulate a few of these designs, like the thermal performance of the building, and undertake some parametric optimization analysis, comparing different cooling technologies. For example, it is not uncommon in Queensland aged care facilities to have multiple split units. We want to be able to compare some of these designs. What's the energy and cost implication of multiple splits compared to a centralised air or water-cooled system, and or compared to a theoretical high-performance radiant vacuum panel cooling. And a couple of energy-related feasibility studies. So one of the engineers have been looking at renewable energy and battery storage with supercapacitors and a backup generator. And as I mentioned before, the hydrogen generation and storage assessment. So these feasibility studies are being undertaken at the moment, and will be ready around February or so, and will be part of our reports later next year. So thanks very much for listening, and I'll be around for questions later. Thank you.
All right, thanks everyone. I work at the University of Wollongong, and today I'm just going to discuss about the 4 integrated design studios that we are running. At Wollongong, we have just completed 2 of those, and we are halfway through completing the other 2 projects. So we have, can everyone see? Probably you can see my screen, yes. So we have, we completed the first 2 integrated design studios. One was, the client was the Wollongong City Council. The second one, the client was Lend-Lease, and the other 2, we had 2 Aboriginal councils providing the site plans for the studios. For the first 2, we have just submitted our final report last Friday, and we completed all the classes about 4 months ago, and those involved undergrad and postgrad students, while the other 2 that we're running this semester, we only have undergrad students for those, and the disciplines that we involved in these studios are from architectural, civil, and environmental engineering in this case, while last semester we also had mechanical engineering in the classes. I will just go through each one of those quickly, but just to give you an idea of what the studios involve. At the start, we have a period where the client provides a brief, the students review the brief, and there is a return brief back to the client. There is a site visit, at least just before the lockdown in New South Wales, just before June, for the first 2 IDSs, we had the chance to do site visits, and they proved to be very useful. And then after that, the students, there's an idea generation period where designs are generated, and in the end, there is a bit more detailed analysis of the designs. And after 14 weeks, the consultants are taking the outputs that we generated during the studios, and they're putting together a vetting report, as with all the studios. So the first building that we looked at was the Ribbonwood Community Centre building in Dato near Wollongong. That was built in 2000, pre-Section J building, and there is a plan to be refurbished in the next 2 to 5 years by the Wollongong City Council, and the council has put together a mission statement, a target to go net zero in operation by 2030. So this was very convenient for us. Our objective for the IDS matched with what the council was aiming. The client gave us a brief at the start that was very much around building services. So he was looking to, the client was looking to upgrade the HVAC system of the building, and then there were some issues around accessibility as well, plant noise and thermal comfort that we looked at during the studio. As I mentioned, there is initially there is a site analysis by the students, so we had very good outputs there, and then a brief analysis where the students are analyzing the constraints and opportunities of the site, and they also develop at that time a business as usual case to benchmark against that. In this case, for this IDS, we were lucky because the client had data, so measured data. So we were able to use the data that he provided, although there were some issues around quality of the data. In the next stage, the students worked in groups. We gave them some criteria, and they put together long matrices where they had to generate ideas, and then they design ideas towards net zero, and they had to find a way to rank those ideas using back of the envelope calculations or sometimes common sense, so that they reflect upon their thinking to be able to adapt some of those ideas in the design. For this building, there were around 45 concept design ideas that they were generated. Again, this was an existing building, so there was a bit less flexibility around the geometry and the things you can do around that. In the end, at the last stage of the IDS, there was a stage there that the students generated building simulation models, and they looked into a bit more detailed design calculations. And while a lot of students went through, classic design solutions, passive design solutions, some came up with some really good ideas, such as carport designs with electrical vehicle charging stations, heat recovery systems, and so on. The consultants in the end put everything together, and they generated a long list of potential solutions for the building, and some additional propositions for extending the generation of the renewable energy beyond what is already in the building. And these ideas will feed into what the University of Melbourne is preparing, the carbon catalogue. That proved to be a very valuable output. And we also looked into what is the best pathway to go beyond at least a 25% of energy reduction compared to the base case. And there was a pathway there that also involved additional PV installation in the building. For the second IDS, the client was Lend-Lease. This was an aged care facility at the Health and Wellbeing Precinct at the Innovation Campus of the University of Wollongong. The Lend-Lease had a very similar commitment about being also net zero in operations by 2030. And they gave us a very detailed brief where they highlighted, of course, that cost is an important parameter of whatever design decisions we will propose. And I should mention that this building that they gave us was at the design concept DA approval stage. So kind of fixed geometry, but with some flexibility around that. Again, site analysis, and the students looked into KPIs, what are the best performance metrics that they should be benchmarking against. And in this case, it was making more sense to look into a per bed per year type of benchmark rather than the traditional annual energy use benchmarks that we normally have. Again, we were lucky to have a in-class delivery, actually hybrid delivery. That was again before the lockdown in New South Wales. So that worked really well. A lot of design ideas were generated. We used those matrices again. They were very useful, and in the end, some very detailed design analysis by the students. Some of it made sense and some of it didn't. But you can see that by bringing together architects and engineers at that stage of the design, you can see graphs that you will never see by an architect at the start of the design. In fact, using MATLAB to generate this type of visualizations where the student looked at the sweet spot between heating, cooling, and lighting loads to find out what's the best way to do, what's the best glazing option, what's the best shading option, what's the best window to wall ratio option, and undertaking energy simulations and daylight and illuminance simulations at the same time. So this wouldn't have happened without an integrated design process. In the end, the consultants put everything again together. They also came up with some additional ideas that we are going to be feeding into the carbon catalog that University of Melbourne is preparing. And some of the observations from these two complete IDSs, we have seen that with existing buildings, you've got a lot less flexibility to modify the design, and the students tended to go through the easy route, the picking easy design options that sometimes are much easier to simulate or calculate against than going through an alternative approach, an innovative approach. But we had some good ideas here with heat recovery systems and, as I mentioned, carports with PVs and so on. The site visit proved to be, extremely useful. The students ended up having discussions with the occupants at that time, and the occupants described their issues around, the cooling systems and the heating system in the building. And with having an existing building, you can also use it to take spot measurements, especially a building like that, which is open to public. The feedback was extremely, good. We probably have never seen such a good feedback in a class in universities. And the consultants really, said, we push the boundaries here in a completely different way that no other university subject would have done before. Now I'm just going to move into the last two IDSs. I know I've got about 5 minutes left. In these two IDSs, we had plain sites, as I mentioned earlier. We didn't have an existing building, although the second one has an old building on it. For this one, the client was Dr. Steve Barrow's Foundation, and he was representing the Lightning Ridge local Aboriginal Land Council, and they want to explore the building a multi-purpose building in Lightning Ridge. And we received a very detailed brief from the client. He was asking for having a community gathering space in there, a cafe, shops, and offices, as well as a restaurant. In fact, the brief was so detailed that the students struggled to meet all the requirements that the brief was asking for. So this was pretty good. Several players, again, consultants were involved in this. The second building came from the Illawarra Local Aboriginal Land Council. Again, a mixed-use development building with an empty site on the side that the council wants to take advantage of, probably to find ways to generate some additional cash flow. This was in Unandera near Wollongong, and this is the old police station in Unandera, and the local council managed to get the site to get the site from the I don't know from where, the government, I guess. So in this space, the students were asked to explore either a knock down and rebuild of the existing building, plus a residential building or a retail building next to it, or a refurbishment of the existing building, and then find a way to take advantage of the site next to it. The building is in pretty bad shape, as you can see. Again, the students went through the usual process, generating a site analysis and a brief analysis. In this case, it was a little bit more difficult because they were working with a plain site. So they had to go through, bubble diagrams and look into the connectivity between spaces and also whether the site is able to, how to better optimize the site to fit all the requirements, the functionality that the client was asking. A lot of good designs were generated at that time. And as I mentioned, we have just completed the classes for that, and we will be looking into developing the vetting report over the next couple of months. The comparison between all the studios, with existing structures, you got less freedom. I mentioned that. With the new developments, you have too much freedom in a way that the students are overwhelmed by choice, and you probably need a little bit more time when you are working with plain sites to develop a final design. And again, some things that will come up later on in these presentations, the face-to-face studios worked a lot better than the online ones. With Zoom is a bit more difficult to have conversations. And a final remark here is that the energy considerations, they are almost extinct in the very early stages of the design. So unless you force the client and the consultants and the participants of the studios to think about thermal comfort and energy right at the early part of the design, the clients tend to say, give me a floor plan and I'm happy with that, without really considering how to better optimize your design towards net zero, unless it's a special type of project. And in classic projects that don't seem to be coming up. And in fact, the architects, didn't seem to be, very much, maybe a bit unfair here, but didn't seem to be very much interested in this. So again, my final slide, the different disciplines here were exposed to areas that they don't feel comfortable with, and that was a very useful exercise for both architectural engineering and mechanical and civil students. Having a very well-defined framework for them to work is the way forward. Give them that, orderly, order process of site analysis, return brief, develop a benchmark. Here's develop a matrix for idea generation and filtering, and then move into the detailed design. That seemed to be a very useful thing to do. And of course, feedback, continuous feedback from the client and the consultants was extremely valuable. And I will close here.
Thank you so much. So my name is Dominik Holzer. I'm the research lead for the integrated design studios here at the University of Melbourne. And Brendon, McNiven and I, my colleague here from Melbourne Uni, we have a bit of a double bill. I will talk about our experience on the design studios, and I will mention some sort of exemplar learnings that we took away from our program that now has run for 2 years. So we have altogether, I believe we have now practically completed 8 of the integrated design studios, with 2 out of those still having some results that need to be worked through and vetting processes that need to happen. But so we are already, maybe compared to the other 2 universities that you heard, we are already a little bit more in the phase of consolidating information and being able to look back into what we've learned, both in terms of the process of design integration and having architecture and engineering students collaborating and having assistance from industry experts who join them in this occasion in their studio setting. So we'll touch on that a little bit, but then I will give you some examples and some lessons learned from different sort of building scales and building projects with different scales and complexity. Brendon McNiven will then follow up with a bit of a comparison, if you want, bringing this into context with some of the learnings that we have from academia and how that might translate into practice. So in terms of my bit, I will give you a very brief introduction to the work. I don't think I need to repeat much of what you already heard from the other 2 universities. And of course, the program is the same. So I won't delve too deep, but I have, I think, 1 or 2 slides on a bit of an intro here from my angle. And I will briefly focus on, there's a focus on design integration, and then lastly talk about the sort of zero carbon design approaches that we've seen, or at least the attempt to go zero carbon. What I find interesting as an academic is that we have what we call, of course, faculties. And if you look at the definition for a faculty, and it is actually a division within a university or college comprising 1 subject area or a group of related subject areas. And I always find that very amusing how many colleagues refer to our faculties as divisions. And it's in a way a symptom on how things also happen in practice. And so clearly, when we look at the way we teach, in normal cases, we teach within our faculty, and students never really get to experience the views and insights from other domains, which is a little bit exaggerated maybe, but when it comes to an actual sort of semester-long subject, these integrated design studios for us are something really special, because we manage to work across these divisions and erode divisions, if you want. And I'm not arguing that we work as one faculty. I think it's still relevant to have separate faculties, but I think there is a mindset that you need to have in order to understand what integrated design is, and to also break down these barriers already on the university education side. Because what we see, and again, Brendon will talk about that much more, if we look at disciplinary sort of reality, we do still see these divisions, and we see issues with contracts, we see issues with time pressures, but from an integrated design sort of cultural aspect, we see issues of language, interpretation of what other people tell you, attitudes, cultural biases, as I discussed, educational differences, and much, much more. So touching on then the lessons learned from our integrated design studio, and they feed into a document that Lou mentioned earlier, which is the catalyst for integrated design, is that I'm going to focus on 3 areas. I'm going to focus on context, I'm going to focus on process, and I'm going to focus on outcomes. When we talk about context to start off with, it's absolutely crucial. What we learn is that it's so crucial to have a succinct brief, that you have a brief that is clear, that describes what the client, in our case, so all the studios that we are running as part of the RDS always have a client, a real life client. It's something that translates the client brief into a very clear set of directives and directions, really, to give to students up front. It helps, and it needs to be a brief that helps to break down the us versus them mentality. So it was very clear for us that we did not necessarily agree to a more sequential way of working, where you have architects doing the design and then the engineers come in at some point and then revise it. But we want to have a context where you have a clear understanding that everyone is a designer, and a clear understanding that there is no us versus them. There is something that we jointly work on. We also learned that it's quite easy to get it wrong. We learned that if you have different output requirements in your academic sort of curriculum for one group versus the other group, it's extremely difficult to make them sing from the same hymn sheet. It's really difficult to break down that mentality if everyone has only their sort of separate targets to work towards. or goals to achieve, then integrated design might be possible, but it's never going to come to fruition in the way that it is when you actually have shared targets and very clearly articulated shared goals. Now, the experience levels of designers is a very important consideration, and it's in our case, there's probably a difference to practice. Our students had to do a lot of catching up with material to understand about environmental design principles in the first place, the whole issues, like the basic sort of fundamental issues related to carbon and so forth. So, and that goes both for the engineers as well as the architects. And of course, we communicate differently. So we needed to pick up in the studios how we can provide common ground and a context for communication that allows the different approaches to communication to be still acknowledged, but then still work towards a common language, if you want, and understand for each of the participants how it is that they can bring themselves in. Now, the other thing we noticed, and of course, COVID has played quite a role in this, is that face-to-face communication still is the gold standard. Now, we understand even in practice, we cannot just always meet up whenever we would like to, unless we are, of course, co-located. But typically, there's a lot of online communication. We had a lot of that in the last 2 years. Some of it worked really well. Some of it didn't work all that well. And the one studio that we had where we had everyone in the room from start to finish, I think we believe by far was the most sort of rewarding experience for everyone involved. So it's still being the gold standard. If you provide a context for design collaboration and integrated design, being able to discuss things face-to-face is pretty crucial. Now, in terms of process, and it ties to what I said earlier about the context, really, it is important that we start with educating people and giving them a base level of understanding. Before people can integrate their design ideas with ideas from others, they need to first have a clear understanding what it is that they need to do, but also have a level of understanding of what the others need to do. We knew and we realized after the second semester that we needed to be very careful in how we curated and how we had somebody, and in our case, it was a studio tutor, to help curate the balance between architecture and engineering. It's quite easy that you move into one or the other direction, and sometimes it is not quite clear. So having active curation really helps. That said, we also looked at experimentation, which is possible in academia, where we say, well, what would be extreme architecture or extreme engineering? So if you, instead of trying to integrate from the starting point, if you try to look at both kind of positions in only at architecture, only at engineering, and what would be some of the drivers there. And that also helps to generate empathy and understanding among the others if they can realize, okay, what would be something that only exclusively the engineers would be interested in or exclusively the architects would be interested in. I'm not saying this should be done always, but we found with some of the studios that we ran, it was really beneficial to have that. Making decisions explicit to others. So having ways where you communicate design and making it very clear the reasoning behind your design decisions. So decision-making and decision support is an extremely important aspect of integrated design, and having transparency as part of that. We realized that when it comes to the process of how integrated design unfolds, that it's really important to have getting the timing right, because there's a limited time frame where integrated design really can happen. We also saw the benefits of having someone nominated as something like a design integrator. So we have, particularly then in the last few studios that we ran, we had nominated that role, and that role can actually rotate within a group. But having somebody put that in that role or in that spot was really benefiting the whole dialogue that we had in those studios. In terms of the outputs, as I said, and it ties back to the briefing aspect, but it's something that needs to be carried through the entire sort of process of a project, was being still very clear about the expected outputs from each participant, avoiding to focus on detailed solutions too early. You still really want to provide a lot of creativity and creative input and a lot of iterations of designs very early on. You don't want to shut down interesting solutions. And finding tools that help you to generate common outputs. So we're working with one passive house plugin for Rhino Grasshopper that really helped the architects and engineers to find and students to find common ground in their dialogue. What we also noticed is that we need to accept sometimes that better performance outcomes don't necessarily improve the design aesthetics, and that might be a bit of a surprise. But depending how it's handled, you could have a building that looks quite similar to a building that's really not optimized environmentally compared to one that does. The devil is in the details sometimes. And sometimes it is visible, but it's not necessarily something that we saw would improve design aesthetics as such. And that was a bit of an interesting finding there. And now I want to take you through 5 examples of building typologies that we have covered, starting from the smaller one that we had. And we had an ambulance station, which was probably our smallest sort of scale that we had as all of the projects. We had a lot of some of the passive measures that students would have taken was looking into solar orientation, looking at stack and cross ventilation, green roof strategies, passive house building fabric optimization, looking at daylight access, looking at double skin facades, and introducing innovative thermal massing. And that also had to do with not just looking at the building itself, but also looking at the building surrounding and how it is embedded in a particular landscape. Some of the active measures, and we will see this a lot, was the use of photovoltaics, which was only providing sort of a certain level of benefits given the smaller size of those facilities. We had decentralized through-the-wall heat recovery systems, mechanical ventilation with heat recovery, displacement ventilation, ground source heat pumps, building integrated photovoltaics, underfloor heating, and air source heat pumps. So these were some of the examples that we saw with the ambulance station. I think we were able to achieve up to about 50% of energy need reduction. So reduction particularly for the ambulance station if we compare to business as usual. The next one we were looking at in terms of the sizing were school projects. Here, in terms of the passive measures, we saw, again, working with the building envelope, window systems, operable facade elements, again, the ventilation being an important one, looking at dynamic shading, which of course we had to align also with having good avoiding sort of direct sunlight into the classrooms, winter gardens with glazed roofs and roofs and green roofs. These school projects were in Canberra. So in Canberra, of course, we had to look for very cold winters, but also pretty hot summers. And some of the results for the active measures, we're looking into, again, photovoltaics, LEDs, mechanical ventilation, and so forth, heat pumps and so forth. We had and on a slightly more sort of experimental, we had suggestions for an algae facade, for instance, but also anaerobic sort of biodigesters were also suggested for and tested for these particular sites. Next one up in terms of size would probably be the aged care facilities that we looked at. In general, it was suggested to consider low carbon construction measures. And this was located in Melbourne. So these would be Victorian projects. Some of the passive measures there, again, orientation being really important, cross ventilation, double, triple glazing, and thermal breaks in there as well. Some of the more active measures, photovoltaics, and this is where we start to see some of the roof areas becoming a bit wider. And in contrast to Queensland, and far north Queensland, it's not that easy for us when it comes to orientation. So we still really have to be a bit more cognizant of how which direction we orient our PV systems, but definitely backing up these systems with battery and energy storage opportunities. Again, ground source heat pumps, water cooling towers, underfloor heating, biodigesters, and high efficiency LED were some of the things again listed for the aged care facilities. We started to then move more into sort of larger scale facilities, and we looked at aquatic centers. They have their own really particular building typology. Many of them have very large roof areas. So when it comes to, again, the passive measures, orientation being a key one here, exposed external pools to capture solar radiation, insulation within the building envelope, judicious rationalization of glazing extent, green roofs and plantings, and then also looking into thermal mass inside the buildings and, of course, the materials then associated to that. LED lighting, rooftop solar, PV systems, and I think we were able to reduce the energy needs with those systems by up to a third to a quarter of business as usual. So they were quite substantial on these large surfaces. Rainwater harvesting, heat pumps, hydrobotanic filter ponds, microinverter technologies, and so forth. So there were a number of more sort of specialist systems and mechanical systems that we were able to test on these particular projects. The last one in my array of building typologies would be probably the data centers. they're sort of monsters when it comes to energy consumption. And I think it's we had about, was it 18 megawatts annually? They're really problematic, if you want, when it comes to the carbon side of things. So we tried to look into ways how this could be mitigated. And some of the passive measures, we realized very early on that our options are quite limited really within the building, because they have a very prescriptive sort of very function-driven sort of layout typically. But it was looking into create a generation of auxiliary programs that had some communal or community sort of benefits, that would provide community benefits. So would have community gardens with greenhouses and pools or bathhouses, and you would pretty much be able to take the excess heat from the server rooms and use some of that heat to and convert that to be able to heat the greenhouses and to also then heat the pools, for instance. And you could use the pool water to kind of help with the cooling. Modular construction method, you can see on the bottom of the image here, you can see one example where this was investigated quite substantially. Some of the more sort of active measures, again, photovoltaics, processes, waste heat exchange systems, and reduction of chiller loads with sort of pump systems, as I described earlier. Overall, I think our client was very happy with the ideas that were generated in terms of how different a data center might look like and how it may play a very different function in its context, because they tend to be rather aliens within their sort of surroundings. One has to be honest, though, on the energy reduction element side of things, given the massive load that we see and energy needs we see from those facilities. We are probably in the low single-digit percentages that we were able to save in terms of carbon emissions or mitigate in terms of carbon emissions on those particular data centers. I think that's all for me for today. I want to thank you for your sort of time, and I will hand over to my colleague, Brendon McNiven.
Right, I'm going to take over from Dominik a bit. So Dominik told us a little bit about the findings in the studios, which are student environments and in some ways a little bit theoretical, but the challenge we now have ahead of us is how we actually translate that into something that's useful and practical for industry. That's just a slide to remind us of the end goal, which is really to break down some of those barriers between the different parties around the design table. And it can, we focused on the architects and engineers and clients. We see that as the power nexus, but there's a whole lot of other consultants and contractors and project managers and cost managers and everything else in there that we need to bring to the table as well. This is a quote from Viollet-le-Duc in 1881, which sort of tells you that the issue between architecture and engineering, not being on the same page, has been around for a long, long time. So right back then, they understood that it was a problem in the design, and he specifically talked about the architects hanging on to old traditional solutions and not really adopting architecture that was relevant to the new materials like iron that were coming through at the time. This is from Herbert, who actually starts to point towards some of the more underlying issues around getting architecture and engineering and integrated design working, which is really all of the people around the table come from very different places, intellectually and emotionally. And so it's a very difficult thing to get everyone designing together. And there's a lot of work done in integrated design in the late 80s and early 90s in a conference called Bridging the Gap in London. And it was mainly run by architects and civil structural engineers. And they talked about how to get space happening and get buildings happening together. And a lot of firms started to do a lot more integrated design. I remember Arup Associates used to have banks of 4 desks where they would have a civil engineer, a structural engineer, a mechanical engineer, and an architect all working at the same workstation, if you like, so that they're constantly talking to each other and exchanging ideas. And that's really what we're trying to do, is we're trying to actually re-establish a bit of that. We know why it's important, and we're trying to learn how to get it working better in industry. And it's getting harder because design is getting more and more complex. The tools are more complicated and the number of disciplines are more complicated as well. I remember when it was novel to have a facade engineer on a project. we now have acousticians, building physicists. We have, in the tens and above in the numbers of consultants and people that need to come together. And we know far more about the building. So getting all of that to work together is harder now than it has ever been. So this is the document that Lou and Dominik referred to. It's called the Catalyst for Integrated Design. And this is one of the documents that we want coming out of the integrated design studios. It's the document which actually takes some of those learnings that Dominik has just been talking about and translates it into something that's a bit more useful for industry and how we might actually get it to happen. So in looking at the different learnings on the way through, they start to fall into three general areas. One is project planning and setup, and that's sort of the mechanics. So that's really day dot with the client and how they're going to approach procurement and things like that. Then there's culture setting, which is actually big team-based stuff, high-level setting of integrated design culture. And then there's the design process specifics that happen underneath all of that. So I'll just go through some of these on the way. And I won't talk to all of these, but in the project planning and procurement box, the three big headings, it's really important to have clear intentions, to set out consciously to do integrated design and to actually make it known to everyone from the start of the project. So that includes writing it into the brief, getting software platforms and project collaboration platforms in place that actually will enable all of that once you get the consultants on board. Procurement on the basis of behaviours is very important, and this is probably the biggest challenge in my view for industry. It's actually for the building industry anyway. Is actually linking fees and payment to consultants with performance. It's very important that people don't just go back to their own little boxes, do their own little designs and get the little fee that's been cut out for them. They need to actually have ownership of the project as a whole, and they need to be instilling good design, whether it's in their discipline or in other people's discipline. And if everybody's working together, like you get in alliance contracting models, where if you come in under a target outcome, like a cost or maybe a carbon usage or an energy usage, everyone gets to share in a bit of that pain, both the client and the consultants, and vice versa. If it comes in over, and everyone has to share in a bit of the pain, but it means that the behaviours are very, very different. And in fact, in talking to some of the consultants, it's almost the opposite at the moment, where particularly for building services consultants, if they spend more effort designing to minimise the systems, sometimes their fees are actually less because they're linked to the actual costs of the systems they're putting in. So this is, it's not uncommon. Our friends in infrastructure do it as a matter of course, and it results in some fantastic design outcomes. So I think we can learn from that. And that document in the top of their integrated project delivery is actually a document put together by the American Institute of Architects, and that's a whole integrated design project procurement framework. So it's essentially alliance contracting with mandated BIM to make sure everyone's communicating and using the same design models along the way. So there's a lot of information and knowledge out there on the procurement side. High-level culture setting is really important. So this is all of the soft stuff, I guess, at the start of projects. Getting the right environment and the right mindset on projects. It sounds strange and potentially negative, but understanding the limitations of traditional design and why we are doing integrated design is important. It's got to be clear to everyone on that project that this is not a business as usual project. We're trying to do better design. We're actually trying to be more innovative and more collaborative and come up with buildings that are exemplars in the industry. It's not just plodding along like we always do. A lot of stuff there on integrated culture, common visions. I think having some specifics in there is important. We found that it's quite easy to talk high-level aspirations, but high-level aspirations actually disappear quite quickly. Once you get into the detailed nitty-gritty of design and documentation on a project. And big picture views is the other really big one that's coming out again and again. We've got to actually be conscious of the process, and Dominik mentioned this around having a third-party facilitator in there, someone who actually is consciously looking at where the design is going, its balance between architecture and engineering, and then actually allowing some flexibility for change and providing a bit of a map on the process, so everyone sort of sees the big picture and not just their own little slice of the pie. Some of the specifics, co-location is a big thing. Again, very, very common on infrastructure projects and larger building projects. One of my favourite projects by Don Bates in MSD at the University of Melbourne is Federation Square. He will tell you that on day one, they took the competition documents for that project and got an architect, he was the architect. They got a structural engineer and a building services engineer together, and they started to workshop what the building should actually look like right from day one of the competition. And it's actually a very good integrated outcome in terms of the way that things work on there. The labyrinth on that project just sits underneath that plaza, does structural work, preconditions the air going in. I think its payback period was 6 years, and it's paid itself off every 6 years since it was finished. That detailed task-based collaboration is very important, and this is a bit of the face-to-face lesson that we learned. It surprised me, I must admit, how important that face-to-face thing was, and it surprised me a bit because I'm from industry and I'm used to working on remote projects, or not remote projects, but projects with remote teams. So I worked in Singapore for quite a while, and it wasn't unusual to have design teams from 2 or 3 different countries all around the table late in the morning and early in the morning and late at night to actually collaborate on the projects. But in those teams, and we heard this from all of the consultants that worked with us on the studios as well, they would always go through an initial relationship building process where you would fly people around the world. Everyone would go out to dinner. I'm looking forward to when that's the case again. There's light at the end of the tunnel. Hopefully it's not too long. But everyone would go out to dinner. There would be a social aspect to it, and then you'd sit down and talk about the design. And just even a little bit of face-to-face at the start of projects to establish those relationships meant that when people were then sitting across a computer screen, at 6 o'clock in the morning, the relationship was a lot stronger, and there was trust and other things there. So it all worked a lot better. So co-location, big thing, and it's not necessarily one big office, but it's actually making sure that you get people physically face to face at some stage. There's lots of design process specifics through there. Senior time allocation was a big thing. That was one of the first lessons we learnt. We actually thought that integrated design ideation would happen quite early on in projects. In reality, it didn't happen until after mid-semester. And the reason for that was that the students, or designers I should call them, were getting up to speed with what was business as usual. So they're going through a learning process. And it's only once you get to business as usual and you feel comfortable with business as usual that you can then actually take those extra steps in coming up with really innovative, multi-function designs. And it's one of the reasons it was so important to have the engineering consultants in the room, because and all of the consultants, because they've been around the block a few times and they're actually able to provide the students a lot of guidance on that business as usual and have a safe place to leapfrog into really exciting design solutions. Dominik's mentioned designing from the extremes. Again, that focus on performance rather than just doing the same thing you did on the last job. Systems thinking is really important. And mutual learning is another thing as well. And actually, those last two items came from the literature review. But having the architects and engineers discuss and educate each other on the project is another great way of forming relationships and actually getting everyone with some ownership in the final solutions. And then the types of thinking, architects are very good at divergent thinking. Engineers are very good at the opposite, which is convergent thinking. And it's really important to recognise that and to make space for both on a design team. And there's a lot of things you need to do to actually make sure you get everyone to the table to be an author in the process. Less problematic with architects who are very used to thinking that way. Much more difficult with engineers who, partly maybe because of their education, we suspect, but they're much more used to having solutions brought to them where they can analyse and actually comment on it rather than being part of actually generating or authoring the solution in the first place. And true integrated design needs everyone contributing to the authorship at the same time. A constructive design review and workshop culture. So it's not a one-off process. It's a very iterative process, which is one of the reasons that balance between convergent thinking and divergent thinking is important. But we believe there's got to be good design reviews that assess clarity and simplicity in the designs. Very, very importantly, multifunctionality of all of the elements on a project. I've worked with a couple of people in my life who refuse to put anything on a project unless it's doing a minimum of 3 things at the same time. And if you apply a discipline like that to your design, it's amazing what you can come up with once you start to combine everything together. Again, the timing of the workshops is really important. If it's too early, people aren't ready to make the leap into these solutions. If it's too late, then things are set in stone. So we found mid-semester, that a couple of weeks after mid-semester to be the ideal time. On a project, it's got to be somewhere towards probably the end of conceptual design and the start of design development, I would have thought. And that last point there is really just to recognise the fact that integrated design doesn't start and stop with any one person or any one stage in the project. It's really important that we follow through and close the loop with people who are going to come onto the project after the design. So contractors and subcontractors, all of those people. It's really making sure that you look after that big picture, and that big picture doesn't get die a death of 1,000 cuts, which often happens on projects if people don't understand why things are the way that they are. So again, going back to that decision making to actually remind ourselves why we ended up with particular solutions, because the solutions won't be just affecting one small part of the project or one discipline. They'll be affecting a whole lot of other things if we've done the job of integrated design correctly. Okay, so this slide is just really to say that there's a lot of work produced through the studios. The students worked really hard, and the consultants put in well above what we asked them to. And I just wanted to really thank everyone for their involvement and the huge effort that went into it. I also wanted to say that they've been a great success in all 3 institutions. We've had really positive feedback, as Georgios mentioned, and all 3 institutions are intending on making these studios a permanent part of their curriculum. So if you have clients or you're interested in being a part of future IDSs, please get in touch with one of the people on the screen there, or search Integrated Design Studios on the AIRAH website, and you'll get those email addresses as well. And this is a list of all of the different consultants, and again, the consultants have been fantastic. And one of the learnings we had is that people really like integrated design and want to do the right thing, but they're held back for a whole lot of different reasons. So that's a really promising thing, because it means that we've got the willingness is there. We just need to figure out the mechanics to to get to the end of it.
Thank you, Brendon.